Bismillahirrahmanirrahim. The topic of discussion is discovery of neutron. यहाँ पे एक इंटरेस्टिंग पॉइंट ये है कि इलेक्ट्रॉन और प्रोटॉन दोनों ही 1886 तक डिस्कवर हो चुके थे और 1895 तक उन दोनों की तमाम प्रॉपर्टीज भी डिटरमिन की जा चुकी थी और यही समझा जाता था that an atom has only two fundamental particles, that is proton and electron. 1932 तक यही समझा जाता था। Although रदरफोर्ड ने 1920 में ये प्रिडिक्ट किया था that apart from proton and electron, an atom has another particle as well, जिस पे चार्ज कोई नहीं है, क्योंकि जब भी एक एटम का एटॉमिक मास डिटरमिन किया जाता, इट वाज अनएबल टू बी एक्सप्लेन्ड, क्योंकि जब भी एक एटम का मास डिटरमिन किया जाता, it could not be explained if we suppose that it has only electron and proton as its fundamental particle. So in the year 1932, James Chadwick discovered this neutral particle called as the neutron, and he was given Nobel Prize in Physics in 1935. Now let's discuss the experiment, the radioactivity experiment performed by James Chadwick in order to understand how these neutral particles can be produced. Now in this experiment we can see that we have a polonium source. This polonium source produce a stream of alpha particles. हमें पता है that alpha particles are actually the helium nucleus. So the polonium metal is serving as a source of these alpha particles. These alpha particles were made to strike at a beryllium plate. This beryllium is our target. देखा ये क्या कि कुछ penetrating radiations produce हो रही थी. These penetrating radiations were checked by a charge detector. चार्ज डिटेक्टर ने कोई चार्ज शो नहीं किया, जिससे ये बात कंक्लूड की जा सकती है कि ये जो रेडिएशंस, हाई एनर्जी रेडिएशंस प्रोड्यूस हो रही हैं, इन पर कोई चार्ज मौजूद नहीं है, एंड दीज रेडिएशंस वर कॉल्ड एज द न्यूट्रॉन्स. इक्वेशन की मदद से हम इसको कुछ इस तरह से शो कर सकते हैं दैट वी हैव द अल्फा पार्टिकल व्हिच आर कमिंग फ्रॉम द पोलोनियम मेटल. अल्फा पार्टिकल are the helium nucleus actually, striking with the beryllium target, atomic number 4, that's number 9. After striking this beryllium target, they formed another nucleus that is of atomic number 6 and mass number 12, that is the nucleus of carbon. And along with that, a stream of radiation having no charge and the mass almost equal to the mass of the proton, and these were named as neutron. And this is how the source of alpha particle, after striking the beryllium, rearranged themselves and formed the carbon nucleus, and a neutron was emitted. And it was checked from the charge detector that these neutrons were having no charge on them. Coming to the properties of neutron, सबसे पहले बात करते हैं that how these free neutron decay. It has been observed that the free neutron having no charge and the mass equal to the mass of a proton decay into a proton with a positive charge and emission of an electron. We know that an electron has negative charge, and a neutrino. Neutrino, a very important subatomic particle, we say that it has no charge, no mass. Coming to point number 2, it has been observed that neutrons cannot ionize gases. Point number 3, neutrons have high penetration power. इनकी penetration power इतनी ज़्यादा है कि हम ये कह सकते हैं कि अगर हम neutrons के path में paraffin रख दें, they will eject protons from that. And similarly, they can also expel high-speed protons from the paraffin, water, paper and cellulose etc. Coming to point number 5. Neutrons can be slow neutron or they can be fast neutron. If the neutron have an energy of 1.2 mega electron volt, they are called as the fast neutrons. But on the other hand, if they have an energy below 1 electron volt, then they will be called as slow neutrons. याद रहे that slow neutrons are more effective. ये slow neutrons ही हैं which are effectively used in the nuclear fission reactions. Coming to point number 6, that is nuclear reactions. देखा ये गया है that neutrons have high penetration power and along with that when they are used as projectile they can cause nuclear reactions. यानी they can produce alpha particles, gamma radiations और beta particles as well. One by one हम इनको discuss करते हैं. For example, how can they produce the alpha particles? It has been observed that when these neutrons strike with the nucleus of nitrogen, they produce alpha particle. This can be elaborated by this equation. This is the nitrogen nucleus. The neutrons, when strike with this nitrogen nucleus, the atomic number is changed to 5, and that is the boron nucleus with the mass number 11. And they have produced alpha particle, which is actually the helium nucleus. So this is how, after striking the nitrogen nucleus, we got a boron nucleus, and along with that, alpha particle is being produced. Now let's see how the neutrons produce gamma radiation. Actually, the slow neutrons, when they hit the copper metal with atomic number 29, atomic mass 65, when this slow neutron hit this copper metal, we get radioactive copper, and that is with mass number 66. And along with that, the radiations are produced which are actually the gamma radiations. Now we have got this radioactive copper. This radioactive copper can emit the beta particle, which is actually the electron, if its atomic number is increased by 1 unit. So we can see that how the production of beta particle can occur. This radioactive copper emits a beta particle, which is actually an electron, and we get zinc nucleus. So this radioactive copper emits an electron which is actually the beta particle, and its atomic number increases by 1 unit.